to our discussion of operations management topics. So today we will be looking at Chapter 6 on processes and technology. And in this particular case, in today's lecture, we'll be looking at process planning, process analysis, specific tools on process innovation, and finally on technology decisions facing organizations as it relates to operations management. Now, in terms of work principle, everybody in workspace in an organization has two jobs, if you think about specifically operations management area, but in general, any business manager. They have to work in the process, that is, a company has set out a specific process for doing work and actually producing products and services. So they actually have to follow that standard operating procedures and produce the product as intended or services as intended for the customer. So in that case, that is the aspect of delivering the results. And while they're doing that, they also have to work on the process. What I mean by that is look into how to improve consistently and continuously improve the process so as to the needs of the customers are addressed over time. And in this case, management has a special responsibility of providing a work environment that enables, encourages, and rewards this behavior. That is not only to follow a process that has been outlined, which is typically how junior and frontline employees are evaluated, but also to work on the process, improve the process. That's where the process innovation area comes in, process improvement area comes in, which is typically middle managers or senior managers' purview. If you look at example from the past, Tucker Automobile, circa 1940s. This is one of the most celebrated failures in annals of American business. If you look at this prototype of Tucker 48, this classic car was shown, released to public in 1947, and it actually was received a lot of excitement from the public. Aerodynamic sheet metal, rear-mounted engine, Cyclops headlight right in the middle, so there are three different headlights. And this headlight moved in tandem. It will face the same area where the steering wheel was. If the steering wheel were turned on the left, the headlight will also veer towards left in that case. But it never made into mass production. So even though it was a design which was received quite a bit of excitement from the public, but production process-wise, it never made into mass production because only 51 models were produced, all largely fabricated by hand at very tremendous expense for that time. Existing equipment and processes were not capable of executing the relatively sophisticated Tucker 48 design on a large scale. So this was a design ahead of its time. This was a product design that was not synchronized well with the process that existed with the company at that time in terms of producing that product. So this model provided an object lesson for need of design for manufacturing. That's something we have discussed in the previous chapters in product design topic. But design for manufacturability or design for manufacturing, making sure that production processes are in line with, we have the necessary production processes to make sure we can deliver the right product design in this case. So so there was a need to incorporate perspective of manufacturing process into the early stages of product design. So if they had done that, maybe such a revolutionary product design may have not come forth, but at least they would have come up with something, a more tamer design, if you will. But that's something that could have been taken to mass production and the company would have survived in that time, rather than only producing 51 units and then not being able to manage the production process after that. So same thing can be said about Honda Accord and Ford Taurus when the option was created. If you think about where is the niche, Ford Thunderbird in this case, I'm sorry, compared to Honda Accord, which actually in 1982 model, just comparison's sake, just to illustrate the amount of simplifying the design choices so that the production process can deliver the necessary quality and quantity that is needed to keep the company afloat. Honda had 32 options, combinations. That is, if you're thinking of shift stick versus automatic, power, window, EX, LX, DX, those models. So all the possible combinations multiply all of them. So if you think of unique models, you could, different colors, etc., you could come up with 32 different options, 32 unique Honda Accords at that time. Compare that with Ford Thunderbird, which was close to 70,000 different unique combinations. Now, even though it is perceivably much better for the customer, but it adds a tremendous cost in terms of unique processes that are needed to handle certain paints or different type of fixtures or accessories that are being provided, and accordingly you have to have different inventories for that, which require warehousing space as well as supplier relationship, and that spells disaster when it comes of delivery, availability of the right product to the right customer at the right time. Whereas in Honda, by managing the expectations, by only offering 32 possible variety of unique Accord options that can be created for the consumer, customer will be relatively satisfied, will be able to get literally every unique combination at any dealership near where they live. Whereas this is almost an unsurmountable task, if not impossible, to get that unique Ford Thunderbird model that you seek out of this large variety of options available. And so because of the expectations that are raised high, it is not, production process may not be able to capture that. So that's something to compare. So that sets the stage for the importance of process planning, which in this case, just to start off with, process is a group of related tasks with specific inputs and outputs. Process design is the task to be done and how they are coordinated among functions. So when you are designing a process, what you are looking at is how variety of activities that are done to produce the product or services, how they should be interrelated. What needs to happen first, and as soon as activity A is done, which activity can be done next. So thinking about that, or certain activities are substitutable. Instead of activity A, can we do activity B first and go back to it? So that's where this comes back, and look at process design of how and when in the production process of whether producing product or services, do you need certain resources, people, organization functions, how they are coordinated and used in this. Process strategy, which is our overall approach of physically producing goods and services, and what type of machines and processes do we use to accomplish that? Do we use a completely automated system, or do we use a lot of handcrafted process that use a lot of manual labor and create a handcrafted goods, if you will, or services? Process planning, which is converting design into workable instructions for manufacture and delivery, which is how can we take a design of a product that has been produced by our research and development department and come up with a manufacturable product design and or service out of that. So in this case, if you think about the process planning and design system, you have a variety of inputs. You have the production or service information as to what that product or service needs to constitute of, which is coming from the voice of the customer. What would they like in the product? What are the features that they desire or they seek? And based on that, other input is the production system information. What type of machines do we have in our facility? What type of resources in terms of knowledge of the workers, training that they have received, certain skill set that they have that is available to us. And what is our operation strategy? How do we go about making money? Are we a low cost provider? That is, cost is a primary criteria, or high quality, or differentiation, if you will. So how do we set ourselves apart from the rest of the competition? And accordingly, that will dictate what will be the operation strategy in this case. Then based on these inputs, those are the antecedents to how the process is planned and designed. And over here, we'll look into the process selection, the type of process selected for a particular product. Vertical integration, should we make product in-house or should we outsource some of that? And we'll address all of these separately. Product process studies, which type of product will be best served by what type of production process. Equipment study, should we use equipment of a particular category or should we need to switch over to a different type of equipment? Production procedure study, the way we produce the product currently, is that the right way of producing it, or do we need to revise our production procedure so as to better produce higher quantity or better quality, or have checks and balances in there? Facility study, do we have the right plant or workspace, or do we need to revise that somehow so that maybe assembly line has to be revised into some sort of a U-shape assembly line, or or it has to be a process type of layout. So those will be coming in here. And out of this process that is done, here comes the output, which is the type of process technology that you'll be using, the type of facilities that you're going to have to produce this product, and type of personnel, and how many, and what type of skill set they need to have. So those are the type of things that will come back in this case. In terms of major factors affecting process design is the nature of product or service demand. Are we a major production house that we make mass production of certain type of products which are easy to produce, but we need large quantity, or we are a designer house of producing one-of-a-kind, low quantity type of product? What is the nature of the demand? And how much is the degree of vertical integration in our business, in our industry? Does all the work that needs to be done to produce a product done in-house, or it has to be done, most of it can be delegated to outsourcing agencies? Production flexibility, in this case, how flexible is the production process? Can we easily ramp up our production, or it's pretty fixed once the production quantity volume is decided capacity-wise? Degree of automation, to what level of work can be done delegated to machines, or most of it has to be done by human workers? And then product service quality considerations coming. So let's look at each one of these in more detail just to evaluate exactly how process design is affected. So first we'll look at nature of product and service demand. In this case, production process must have adequate capacity to produce the volume of product and services that customers need. And also provisions must be made for expanding or contracting capacity to keep pace with the demand patterns. And we'll cover capacity issues in a chapter later on when we discuss capacity. Some type of processes are most easily expanded than others. So more flexible processes where more human work is involved are easy to expand, ramp up production, as compared to the ones where automated production is, because over there the capital outlay is much more to add capacity. In terms of product service price affects demand. So depending on how much is the profit margins will also impact what you can, what type of demand can you expect for that product. And okay, so pricing decisions and the choice of process need to be related to each other, synchronized in that case. So let's move on to degree of vertical integration. And in this case, vertical integration is the amount of production and distribution chain that is bought under the ownership of the company. How much can you centralize, or how much can you delegate out to other outside vendors or outsourcers? So this determines how many production processes need to be planned and designed, because the more you have to delegate, you need to create a set of procedures of how to evaluate the quality that is being received from your vendors, versus if you're going to do it in-house, at how it all has to be integrated into your existing activities that you already are doing. So decisions of integration is based on cost, availability of capital, quality and technological capability of the company itself, and several other factors. Strategic outsourcing, and which we'll cover in a little bit more detail, is the lower degree of integration. That is, more of the stuff is being done by outside vendors or other companies. Is this outsourcing of processes in order to react quicker to changes in customer needs. So the reason one outsources is so they can focus on their core competencies, and anytime there is a change in demand or customer preferences, companies can react quickly by modifying the order with the outsourcers, and don't have that much of capital investment in inventory resources or technology resources to build up production volume capacity, or even bigger facilities personally. So there is a lot less invested that way. So they can easily react to changes in customer needs, competitor reactions, or other technology changes. So in terms of outsourcing, you can see there are various benefits that come in. Of course, obvious one is the lower cost, and in terms of speed, because other companies do this for a living and they can do that job much better as compared to somebody else. Capacity-wise, as a company, when you outsource, you have instantly expanded your capacity to produce that part, because now you have an outsourcer doing that for you. Reliability, because if somebody, there is focus, the outsourcers have been doing this for a long time, and there are strict qualities that can be looked into. So the product that they are, components that they are providing can, in many cases, will be of higher reliability as compared to what company may be producing. Same thing with quality, better quality and expertise as they know. So, but there are, you can see the benefits of outsourcing. You could save time, that's the speed, best technical staff, which is the expertise, benefit from rich experience, so your reliability is coming in there. Focus on core business activity, that is, you lower your own cost as well as excellent support. So cost savings. So all those things are really coming in here in this case, even though there is a lot of backlash on sending, you can see a couple of cartoons over here which allude to the point of nations trying to somehow address the side effects of outsourcing in this case. Outsourcing continuum, how companies outsource, if you think in terms of all the way from minimal outsourcing, which will be a single contract, one-time effort of, okay, this one time, normally we produce everything at home within the company, but just this one time we need to get some aspect or some portion of our production being done, or components that need to be produced outside, and that is a single contract, short-term contract or single purchasing decision. So it could be as minimal as that, all the way to strategic alliance where you create a long-term supplier contract, collaborative relationships are created, and then you can go even further on this continuum all the way to high integration where joint ventures are created, equity partners are created. So now you become partners in production of this goods and services. So in this case, there are both positives as well as some backlash associated with that. Next, we'll address the issue of production flexibility, which is product flexibility, ability of production or delivery system to quickly change from producing one product to another. So how quickly can company switch from making one type of product to another, or volume flexibility. That is how they can increase or decrease their production quantity. So there are two different types of flexibilities that are measured in company. This is the ability. Volume flexibility is the ability to quickly increase or reduce the volume of the product or service produced or delivered without having the side effects of hurting their bottom line. Then we'll also look at degree of automation and advantages of automation. It definitely improves the production quality because machines tend to be more reliable than human beings, less variation. So overall quality of the product will be higher, but improves product flexibility. You can easily shut down the machine for a number of hours whereas it's harder to not pay a worker who has been brought in for 8 hours work when you only have 4 hours of work. So wages still have to be paid. So that's where product flexibility or switching from one product to another is easier in this case because of the fact that all you have to do is change the tool on the machine or the die, whereas unless the worker has been trained to create a new type of product, they may not be able to have that flexibility. Reduce labor and related cost in this case because that's a fixed cost, one-time cost of investing in production, whereas labor, it's a variable cost. The more you're producing, the more you have to pay in that case. Disadvantage of automation, equipment can be very expensive. That capital fixed cost that we talk about is pretty high in millions of dollars. So it's a long-term decision, not just something you can make on a whim. Integration into existing operation can be difficult because that new equipment has to mesh nicely with the existing equipment that you may have. In terms of the last aspect is product and service quality. Old viewpoint is high quality products must be made in small quantities by expert craftsmen. But the new viewpoint is high quality product can be mass produced using automated machinery, as we talked about earlier. So automated machinery can produce products of incredible uniformity consistently. If ketchup bottles are being filled at a manufacturing plant, Heinz plant, every single bottle can be expected to have the requisite amount of ounces. So the production uniformity of a bottling plant or any other type of service that is being provided by machines will be highly uniform. So that's where the quality does improve. The choice of design of production process is affected by the need of superior quality in this case. So let's move on to our discussion of process strategy now and look into, we talk about vertical integration. Vertical integration basically is the extent to which the firm will produce inputs and control outputs of each state of the production process in this case. And capital intensity, as we mentioned earlier, the automation, mix of capital, which is equipment, automation, and labor resources used in the production process. So that's the definition. So higher capital intensity refers to higher level of automation. Lower capital intensity means more manual work by actual human beings. And process flexibility that we talked about earlier is with which resources can be adjusted in response to changes. And finally, the customer involvement. In case of services, you are looking at customers become the co-producers of such services that are delivered to them. In terms of process selection, you have a wide variety of processes that match with the type of products that are being produced. So in this case, there are 4 different categories that have been listed over here. Project, one-of-a-kind production of products to customer order. Example will be a high-rise building or creating of a ship in a shipyard, if you will. It's one-of-a-kind project. Or building a blockbuster movie or creating a new airplane. So those will be all one-of-a-kind production processes. Whereas batch production, where you're creating a batch of certain product, few items at a time, but each batch has the same exact product, and then after that you may switch to a different type of product being produced in the next batch. Mass production, now you're producing less variety and more quantity. In this case, produce large volumes, standard product on a mass market. And then continuous production is very high volume. Direct mail go through continuous production. Dairy, milk production and pasteurization happens on a large volume. Textile mills run on oil refineries will be all continuous production environment. So these 4 processes can be put in a matrix, a product process matrix, which has been given to us by Hayes Wheelwright of Harvard Business School. In this case, you can see standardization is pretty low, as well as the volume is pretty low. So you have high variety over here. Low standardization means high variety. So projects are one of a kind, so extremely low volume. And then you have the batch production, where slightly more standardization, but higher volume as well. Then you have the mass production, and then continuous production in this case. Now this can be viewed, there are different type of processes, so you can see exactly all 4 of these, you can tend to create a variety of can compare and contrast these processes. So type of product in a batch, in a project is unique, whereas in batch it's made to order, customized. So think of a cookie company making a batch of oatmeal cookies, and then the next batch, next tray could be raisin cookies or chocolate chip cookies. So that's a made to order, whereas mass is make to stock, and then commodity bread production or milk, that 2% milk, etc., would be commodity items. Type of customer is one at a time, because this is a unique type of project. Few individual customers for batch, mass market for mass production, and then also mass market for continuous production. And then you have product demand is infrequent, because this doesn't happen that often, and each time the requirements are different. Batch, it fluctuates, goes up and down, and this is stable and very stable for mass and continuous. In terms of demand volume, you can see volume is very low to very high, going from a project to continuous. Number of different products, variety is extremely high over here, and goes to extremely low all the way to continuous. Production system, this is a long-term project, takes a long time, all the way to continuous process industry, where it becomes much more of a completely automated environment. In between, this is a job shop environment for how do you produce the product, a lot of manual labor, or more machines than projects, but still less than repetitive assembly lines that you typically see in mass production. And equipment that is used is varied. A lot of work done by hand or common use machines. Then general purpose machines are used in batch production, lathes or milling machine or drilling machine, which is, or in case of bakery, a standard oven. So that can be used for anything, not just for cookies, but also for making croissants or something like that. And then the machines become special purpose and for mass, and highly automated for a continuous environment. Primary type of work in this case is specialized contracts, and then over here for batch is fabricated, a lot of fabrication that is done. Assembly over here and mixing, treating, refinery type of work that we mentioned earlier, like creating yogurt in a dairy or treating, painting automobiles or refining of oil, if you will. So in terms of worker skills, you are looking at experts, craftsmen who actually have lot of high skills because manual labor is much more important over here. These, in batch production, there still are multi-purpose workers who have variety of skills. They can do multiple things. And in terms of mass production, they need to have specialization in, they do what they do in a smaller set of skills, and they need to do a good job of it. And over here, in continuous, they don't really actually do a lot of work except to monitor the equipment in this case. In terms of type of processes, advantages in project are custom work and latest technology that is used, whereas in batch, you have the flexibility and quality. In mass production, focuses on efficiency, speed, and low cost, and whereas in continuous, even more efficiency, even providing extremely large quality and easy to control because of monitoring of the disadvantages. Again, in this case, you can see the opposite. Non-repetitive, and that's the downside. Even though if you need to create more of those, every time the same amount of effort is needed. Small customer base, expensive. Batch over here is costly compared to mass and continuous, but difficult to manage also because of the common purpose, general purpose machines that are being used in this case. Capital investment is higher because of machines involved and lack of responsiveness. Whereas over here, because of highly automated environment, it's difficult to change. If you want to stop a painting of a station, which is highly automated of assembly line, it may require, still have to go through a lot of, you're looking at a considerable expense, or you have to stop an oil refinery for whatever reason. That'll constitute a very significant, done at a very significant cost. Far-reaching errors and limited variety. Examples over here, as I mentioned earlier, when we started this comparison, construction of high-rise buildings, shipbuilding, spacecraft, those will be all examples of one-of-a-kind project. Batch, machine shops, print shop, bakeries, education. Mass production, automobiles, televisions, computers, fast food will be all. And then finally, paint, chemicals, and food stuff. Okay. Oh, okay. I forgot. Okay, so yeah, and let's now look into product life cycle, how it affects the process decisions. And in this case, you can see a life of a product all the way from introducing to the customers for the first time, introduction, all the way to its growth, where customer acceptability comes in, and then maturity, where enough competition is out there, all the way to decline of the product, where product demand is waning off so that other people are moving on to the next product. So you can see the entire life cycle of the product from early stages to the later stages. And in this case, how product volume, focus, etc. changes in this case. Now, in this particular scenario, what you're looking at is product life cycle, series of changing product demand. Consider product life cycle changes in introduction, growth, maturity, and decline. And facility and process investment depend on the life cycle. So for example, in introduction, when the product is just introduced to the customer for the first time, you're making custom products. So almost think of making prototypes, few products going out, and just to get feedback from the customers, early adopters. Whereas in early growth, you standardize certain things, but certain things you're still leaving for modification based on the feedback. Whereas in late growth, in this case, which is still part of right here, the second part of the growth, product becomes standard after looking into best practices. And in maturity is highly standard. That is, you don't vary the product that much. In terms of volume, goes from very low to very high, as we mentioned earlier, because this is where we are adopting mass production. Focus is process-based production environment to product-based, which is assembly line, continuous environment. Financial grading will be it's made to order in early on, whereas make to stock in this case. And then batch size, very small to large to very large in terms of volume. So again, in this case, one can see how that will play out. Concept of production process life cycle. So production systems tend to evolve as the product moves through the product life cycle, as I showed you in the previous slide. Product life cycle and production process life cycles are interdependent. So as the product life cycle goes from introduction to growth to, in this case, it goes from introduction to growth to maturity to decline, you can see production process life cycle also has to be modified. So production processes, which will decide based on what type of production cost you're going to have, what type of quality and production capacity determination will be made. And that will dictate the volume of the product that the company theoretically is capable of producing. Now, that will dictate the volume of product that is actually, what can be sold to what actually is sold after factoring in the various demand, etc. And from that, you actually synchronize the type of production process that can be justified. So that's where you're looking at matching product life cycle with process life cycle. In terms of process design in services, there are 3 different schemes for producing and delivering services. You have quasi-manufacturing, which is almost like a pseudo-manufacturing environment, services produced as products. So physical goods of the service part is dominant over intangible service. So less of the services and more of the product component is more important. So for example, a restaurant meal could become a product that can be sold in a supermarket. So there is that restaurant services component is reduced to minimum, and now just the product itself is being sold by itself. So that will be a quasi-manufacturing in this case. Production of goods takes place along the production line. Operations can be highly automated. So for example, a restaurant is famous for their salsa, and they take that salsa or sauce that they make and try to market it through supermarkets. That's an example of a service which earlier was provided by a full-service restaurant is now being provided in a quasi-manufacturing environment. Operations can be highly automated, almost no customer interaction, as I pointed out, little regard to customer relations. So banks check encoding operation, which is in the back office, is an example of something where customer service is minimized. And so the intangible aspects go away. It's strictly production operation in this case. Customer, the other type of process design is where customers are participants. They are the co-producers of services. Physical goods may be a significant part of the service. Service may be either standardized or customized. So self-service is an example of that in this case. High degree of customer involvement in the process, so ATM, where customer has to do all the work with the machine. Self-service gas stations, you can go to many stores such as Home Depot or Safeway, and you can go to a self-checkout is an example of customer as participants. You have to take your cart throughout the supermarket and basically help yourself with the groceries, put them in the cart, and now even check out on your own, if you will. And so that's an example of customer as participant. And the third design is customer as product, which is customer is the main focus, and everything is being done. All the processes are created to serve that customer. Service is provided through personal attention to the customer. So you can think of fashion boutique stores where customer just comes in and sits down and all the work, everybody just caters to them and offers them the right, shows them the latest fashions and even help them make certain decisions in terms of purchase. Highly customized service on the customer and high degree of customer contact. Perception of high quality where everybody's doting on the customer. A customer becomes the central focus of the process design. So medical clinic where patient is the main concern, or a hair salon where customer just comes in and sits but is not required to participate in anywhere except for just sitting and everybody else takes care of them. If you think of a spa, those type of examples where customer is a product. Now let's go back to the break-even analysis. So process selection, how it is. So study cost trade-offs based on demand volume as to which type of process should we select in this case. So there are fixed costs as well as the variable costs, as I mentioned earlier. So fixed costs are constant regardless of the number of units produced. And variable costs vary with the volume of units produced. So as if we produce more units, per unit basis, the variable cost will go up. Revenue is defined as the price at which the item is sold, and total revenue is basically selling price per unit times the volume sold. Profit is difference between the total revenue and total cost. So in this case, let's look at the formulas associated with this environment. Total cost is the fixed cost plus total variable cost. So that is the cost equation. So total cost is TC plus fixed cost is, as indicated in the textbook, is CF plus volume times the variable cost per unit, which is CV. And on the other side, the revenue equation is total revenue is volume times price of the product, selling price of the product. And profit basically is total revenue minus total cost, which you take the volume times price, the total revenue, minus the total cost portion, which is CF plus VCV. Okay, so those are the numbers that I've already explained, the various symbols over here. So let's go ahead and look at the break-even. At break-even, your profit is 0, which means total revenue equals to total cost. In that case, the equation, if we plug in the right numbers for total revenue, which is equal to V times P, volume times price, and the total cost is the CF plus VCV. So in this case, you can see the only thing which we don't know, unknown, is the volume. What is the quantity of break-even? So bring all the aspects which have an unknown on the left side. So you bring the VCV on this side, which is VP minus VCV equals to CF. And in this case, take the V common out. So V and in parentheses P minus CV will give you CF. And take this, divide both sides by P minus CV. So that goes away and it is divided from this side. So this is the break-even formula, which is break-even quantity V equals to CF divided by P minus CV. So this is what is used to solve the break-even volume. So let's take an example of this just to illustrate that. So if our fixed cost is given to be as $2,000, variable cost per unit is $50 per unit, and selling price is $100 per unit. So in that case, 2,000 divided by 100 minus 50, which is 2,000 divided by 50 equals to 40 units. So if we are able to produce and sell 40 units, we break even. We are able to cover our cost. Anything over 40 units that we are able to sell, that's profit in the bank. And anything less than 40 units, that's still, we are in the red in this case. So that gives you an example. In this case, cost, which even if you're producing 0 units, is 2,000, which is the fixed quantity. And then it starts going at this slope, which is the $50 for every unit being produced. So that's the slope, total cost line. Whereas total revenue line is going at a higher, faster, much steeper slope, which is $100 per unit of price. So they end up meeting at 40 quantity, 40 units, which is the break-even point. So that's a way to explain things in this particular case. Now, if you look at the process A versus multiple processes, so you can compare the two processes at what point you're indifferent between using process A and process B. So in that case, what is the break-even point where both process A and process B have the same cost? So in this case, comparing the cost of process A with cost of process B. So in this case, let's say we have process B, which has a higher, in this case, we have process B, which has a fixed cost of 10,000 units and variable cost of $30 per unit. Compare that with the existing process that we discussed in the previous example. So in that case, 2,000 plus 50V. So in that case, bring all the unknowns on the left side. So subtract both sides by 30V. So 50V minus 30V is 20V, and that cancels out over here. And bring all the knowns, which is 2,000, subtract both sides by 2,000. So that 2,000 goes away. And this is 10,000 minus 2,000 is 8,000. So 20V is 8,000, V is 400. So now you have a break-even of 400 units. That means anytime you're making less than 400 units, you better choose A because that has a lower fixed cost. But over 400 units, you should choose B because at that time, you are not only covering the fixed cost of 10,000, but after that, your variable cost is a lot cheaper. So it makes more sense to go 401 onwards to choose process B. So that's the break-even in that case. So now let's look at process plans. And in this case, we'll look at a variety of tools that are available to document the process and see how things are provided or services delivered. So set of documents that detail manufacturing and service delivery specifications. So one is called the assembly chart, and other is the operation sheet, and then we have quality control check sheets that we have mentioned also in the previous chart. So assembly chart, this is an example of assembly chart of how to create a burger, a cheeseburger in this case. Often called goes into charts, which actually comes from the word goes into. And even though it was created by Italian mathematician, but both the assembly chart as well as goes into charts are the terms which are used interchangeably over here. Used to provide overall micro view of how materials and sub-assemblies are put together to form finished goods, and often a schematic model that defines how parts go together. The order of assembly, so in this case, first layer of assembly, what you want to put in, sesame top seed bun, and then beef patty in certain order, salt, cheese, lettuce, that will go into the first sub-assembly, and then lettuce, sauce, and onions that are going in. So you have the beef patty, which is processed with salt and cheese, and then you have lettuce, sauce, onions put together in the top layer. And then you have the middle bun right here. And then in this case, add another beef patty, and as well as lettuce, sauce, onion, pickles, etc. That will go in there in the bottom bun at the very bottom. And all of this will go into a wrapper, which is a completed Big Mac that is being created. So ideal for getting a bird's eye view of the process for producing the most assembled products. List major materials, components, sub-assemblies, operation inspection, and assembly operations that can be incorporated. Now let's go ahead and look at the operation sheet. So this is an example of a crevice tool which is used for hand vacuums, just to take out dirt from corners in a household. So you can see exactly what is the operation sheet, how this is created. It's pour in plastic bits, insert the mold, so you can take the raw material, put it in a mold, check the settings of the start machine, collect parts, lay flat, all the. So again, it's a complete production process of creating all the way from plastic bits throughout the various, how much time it will take which machines are being used. If you take the plastic bits, they are going to come from department 41. They'll be machine used as injection molding for 2 minutes. Insert machine mold, and in this case, you're using a specific type of mold, and for 2 minutes, check the settings, and that's where a variety of machine numbers that are being put in here, that's what's going to be done. So all this is going to be done in department 41. So these are operation 10, 20, 30. The reason they go as 10, 20, 30 is in case later on process is revised, and then you need to insert another process in here. It's easy. Rather, if we call it 1, 2, 3, 4, it's hard to put in another number between 3 and 4. So then it becomes 3A, which becomes confusing. So the convention is to use 10, 20, 30, 40. That way, if we need to increase, let's say, add additional steps in here, let's say one more step in here, we can always call it anything between 31 to 39. And it still will can be computerized, computer coded accordingly without all the remaining numbers changing and confusing things back and forth. So again, you can see collect parts, lay flat, plastic finishing, that's a different department. So now one can easily visualize how it's going from department 41 to 51, then going back to 42, then back to 51 to finish it off. So that's pretty much and how much time it will take to create this product. Process analysis, a systematic study of all aspects of the process. So this is where trying to see how one can work on the process, as we mentioned in the very first slide, which is how can we make it faster? How can we make it more efficient, less costly, more responsive? So over here, these are the tools for process improvement after analyzing the process, how we can improve it. Process flowchart, diagrams, and maps are used in this case. So process flowchart, you can see a variety of flowcharts available in Microsoft Visio. In this case, that's a software that's readily available to most managers and companies, and they can easily use that and identify a specific diagram, and then whether it's a brainstorming, organization chart, pivot, or you can create a basic flow chart right here. You can create cause and effect diagram, several other fault tree analysis that we mentioned earlier, variety of diagrams, TQM chart, etc. But flow chart is indicated right here, which can be used in this case. Process flowcharts look at the manufacturing of products or delivery of service from broad perspective, incorporate non-productive activities, which are inspection, transportation, delay, storage, and productive activities, which are operation. Determines, basically, when you're building a flowchart, determining the objectives, what is it that one has to do, define the process boundaries, define unit of flow, and then choose the type of chart, observe process and collect data, and then map out the process and make sure it is the way you intended as how it is actually done in the company. Here is an example of process flowchart. The process flowchart symbols are a circle, which indicates operation, as you can see right here. That's a circle. Inspection is typically denoted by a square, which is right here in the middle. Then transportation is denoted by arrow, as you can see right here. And delay is indicated by D, which is also listed in here, and in some cases can be indicated in the process. And storage is the inverted triangle. That's a traditional way of showing the storage. So those are the 5 symbols that are used in here. And in this case, you can see how a flowchart for apple processing can be created as a part of the flowchart. You can see unload apples from the truck, how much time will it take, and how much distance it has to be traveled. So move to inspection station, it takes about 100 feet. So once you unload them, you move them and indicate this is an operation which is unloading the truck, whereas this is transportation. The next one is inspection, weigh, inspect, and sort. That takes 30 minutes. Then move to storage. Again, that's the move. So again, you can see wait till needed, and that's now it's sitting in the storage. And move to peeler as needed. In this case, 20 feet, and so on and so forth. So you can go through the whole process and you can get a sense of total minutes taken is 450 and total distance moved so far is 190 feet. So one can easily try to figure out of this 450 minutes, 360 minutes is just waiting till needed. So one can easily figure out, is there a better use of that time? Do we need to buy the apples that much far in advance, or something else can be done? So in this case, one can also create a flowchart in Excel. Microsoft Excel can also provide the necessary step, tools in it to produce that. You can see weighting, the D, all the various decision points, as well as the actual items that are listed in here. We can also create a flowchart for services, process map, and in this case, this is called the swim lane chart of a restaurant service. And in this case, items are actually intentionally sorted out by whether it's a customer doing it, the server or waiter doing it, salad chef doing it, or dinner. So which person is actually, or dinner chef is doing it. So, or it could be kitchen, back office, the cleaning busboy is doing it. So you can pretty much separate all the activities in this case that is being done in order to provide the service. So customer has to place the order. That is what customer has to do. If the order is complete, yes, move on, give soup and salad to chef. So again, order is given, and then a salad chef's job is to create the salad and then give the order to the waiter, who will bring it back to the customer. And again, you can see all the decisions that are being made and customer interaction. So you can see in here, the green color indicates the action, which is typically in terms of the rectangle that we mentioned. The start and end are given by that elliptical sign, and then the diamonds are the decision-making points, and the arrows indicate the flow or direction of activities. You can also have a flow chart of simple value chain, which is how value is being created. The actual flow of product is moving from supplier to customer, whereas information is moving back in terms of feedback. Process innovation is looking at how process could be improved. In this case, if you look at processes that are in place, and this is where once continuous improvement activities peak, that's the best you can do with current process, and one looks into how can we re-engineer the process to create radical innovation, and in this case, time to re-engineer the process and create that breakthrough improvement so that we move on to a completely different plateau. And then slowly, once this new process is incorporated and then you slowly, continuously improve the process. So that's a way to look into total redesign. And when you think about process redesign, it is from function to process. So all the way from accounting, purchasing, manufacturing, sales, various department silos, to creating a process, which is product development process, which requires input from all the various departments. Order fulfillment also requires input from multiple departments, same as supply chain and customer service. So that's a way to think about it. And in this case, process innovation process is where customer requirements, all the way from strategic directive, and what is the high-level process map, then detailed process map, how are we going to go about creating this process improvements. And in this case, one can easily look into high-level process map, which is generic in terms of input, various sub-processes, and outcomes, output, and whether or not it meets the goals. So specifically looking at online order processing, customer places the order, and within this black box, you're doing a lot of things, whether it's verifying the stock, process the order, verifying financials of the customer, checking if they have the capability of paying it, process the payment, and then once it's done, order is filled, and fill customer orders within 2 minutes in that case. And the process, how do we go about creating a system for that? One of the things is to remove the waste. Any activities that is not adding value, that has to be removed. Simplify so that anything that is adding unnecessary complexity has to be taken out. Consolidate similar activities so that to standardize things. Link processes to create value, as I mentioned, only in the value chain design. And link the swiftest and most capable enterprise, let the swiftest and most capable enterprise execute the process, which is to make sure that certain entities that are be able to deliver that activity or the production process or service process should be able to handle that. If it's outsourcing, so be it, outside vendors, or if it is within the company, that's fine. And make sure the processes remain flexible for any time, any place, any way, so that you can respond to changes in customer demands and needs. Capture information digitally so that one can easily provide the necessary information and at the source and propagate it throughout the process so everybody is in sync with what needs to happen. Now, in terms of principle of redesigning the remainder of it is to provide visibility through fresher and richer information about up-to-date information about process status so that everybody's working with most recent information about what to make, when to make it, where to make it. Fit process with sensors and feedback loops so that it can prompt action. So in this case, anytime the process is going out of control, one can look into how it needs to be remedied. Add analytical capabilities to the process, which is obvious in this case, analyze the process and see how it is performing and if it needs to be improved. Connect, collect, and create knowledge around the knowledge. This is the area of knowledge management throughout the process, and make sure collect it from anybody who is interacting with the process. May that be the customer, may that be the service provider, everybody in this case. Personalize processes with preferences and habits of participants, making sure that that process becomes innate, second nature to the people who are actually dealing with it. How do we create innovative ideas in this case for process design and analysis? Vary the entry point to a problem. In trying to untangle fishing lines, best way to start from the fish, not the pole, as an example. So try to figure out from the customer side rather than the service provider side or the person producing the product side. So from a customer side of view, try to see how things should be sorted out. Draw analogies. A previous solution to an older problem might work. So that's where the knowledge management comes in handy. If you have a repository of how we have handled things in the past, that will save a lot of time in this case. Change your perspective. Think like a customer. Bring in persons who have no knowledge of the process so that they can provide a fresher view of things in terms of being a sounding board for ideas outside the industry. Try inverse brainstorming. What would increase cost and what would displease the customer? And then let's see how not to do that. And then that's a reverse brainstorming. Rather than saying how can we do certain things, inverse brainstorming focuses on how not to do those things. And that's a way to identify a variety of solutions in many cases. Chain forward as far as possible. If I solve this problem, what will be the next problem? So try to see the linkages among problems. Use attribute brainstorming. How would this process operate if our workers were more mobile and flexible, if we were to provide them smartphones or mobile apps to do certain things? And so one can easily see how the process will be modified. If there were no monetary constraints, how will we be doing things differently, which will try to help us identify certain constraints which we may consider as permanent constraints, may be there just because we don't have at one time we didn't have the money to take care of those issues. Or if we had perfect knowledge in advance, what are how things will change. Technology-related decisions, financial justification of technology has to be done. Purchase cost, include add-ons and make technology work. So a lot of times when you're buying a process, a new technology or machines, one has to look at what is the purchase cost. Also have to look at operating cost, which is the variable cost of running that machine, upkeep, how the technology will be used, and what is the annual savings also had to be noted down. By investing in this machine, what are we improving our productivity of the workers, or are we making the product faster, more product in the same amount of time, or with less resources? So there are some annual savings. It's like saying buying a new refrigerator, Energy Star refrigerator will save on electric cost over cost of electricity over time. So those will come under annual savings. Or revenue enhancement. New technology can enhance revenue in this many cases. Also, financial justification of technology. Replacement analysis is used in this case. When to upgrade to new technology depends on competitive environment. Risk and uncertainty. It's risky and invest into these technologies, so that's another consideration. And piecemeal analysis, make sure new and existing technology are compatible in this case. So you can't just buy a brand new technology and make an island of automation which does not communicate or work well with existing technology, then nobody ends up using it. Components of e-manufacturing, in this case, you can see a variety of components all the way from CAD, computer-aided design, group technology, computer-aided engineering, computer process control, product design, manufacturing, product life cycle, product definition. So then you have business to business, business to consumer, barcodes, RFID, electronic data interchange, XML on the internet, enterprise resource planning, supply chain management, customer relationship management, decision support system. Again, a variety of artificial intelligence, internet, etc., CNC, computer numerical control machines, conveyor. So this is all the manufacturing side that is coming in. This is the product, this is the IT. So conveyors, automated guided vehicles, automatic storage and retrieval system. Then you have the flexible manufacturing system, robotics, process control, making sure the process is in sync. This is used in highly automated continuous manufacturing environment where workers are only monitoring the process. Cells, which is used in group technology and centers, multiple factory sites and suppliers, so one has to monitor the coordination among those. Then processes-wise, STEP, CAD, CAM, which mentioned earlier, computer-aided design, computer-aided manufacturing. Then computer-assisted production process, sourcing, and e-procurement. So you have a variety of e-manufacturing tools available in this universe. And in terms of product technology, computer-aided design is create and communicate design electronically. So all the designs of a new product are being done on the computer so as to save the existing version, modify it, look at what-if scenarios, and if need to go back to the one step back, regress back, and come up with another variety somewhere else. It saves a tremendous amount of time. Group technologies classify design and families into easy retrievable and modification. So all the nuts may go in one area, all the bolts may be in a separate family, etc. So you can try to see what all the various bolts we have for fasteners to use in a particular product. So that's how group technology facilitates that decision making. Computer-aided engineering tests functionality of CAD designs electronically to see if we design the product using CAD this way, will it really work out in unique stress environments or not? So that's the computer-aided engineering. Collaborative product commerce, CPC, and this is facilitate electronic communication and exchange of information among designers and suppliers. Then you have product data management, keep track of design specs and revisions for the life of the product and see how over time, product design has been changed. So when you're coming up with a new version of the product or improvements in the product, one can easily look into and see if there is what type of design iteration really worked well, version 2.1, version 2.2, and now we need to move to version 3. So what worked well, what did not work well, and you keep track of throughout the life cycle of the product. That helps you in future product innovations. Product lifecycle management, integrate decision of, as you mentioned earlier, involved in the product development, manufacturing, et cetera, throughout the life, recycling, disposal, throughout the life of the product. And product configuration, define product configured by customers who have selected various options, usually from the website, and then see what are the management of those configuration is an important thing. How many different much variety should be offered in this case. Process technologies in this case, then you have the standard of exchange of product model data, which is STEP. Set standards for communication along various CAD vendors, translate CAD data into requirement. Then you have computer-aided design and manufacture, CAD-CAM, electronic link between automated design and automated manufacture, computer-aided processes, and in this case, process plans based on database of similar requirement. And we mentioned e-procurement, buying materials and sub-assemblies through e-marketplace online from suppliers. Then you have manufacturing technology, computer numerically controlled, which is machines controlled by software to perform a range of operations with the help of automated tool changers, collect processing information and quality data. Flexible manufacturing system, which is a collection of CNC machines to produce an entire complicated product, completely automated manner. A collection connected by automated material handling system produce a variety of parts. Robots can try to mimic all the functions that a human being can do, but in a hazardous environment or extreme work conditions, they can be worked to provide consistency. Programmable manipulators that can perform repetitive tasks, more consistent than workers and less flexible, but at the same time, if they can be used in conditions which can adversely affect human beings, but you can use robots in that case. Conveyors, fixed path material handling, move items along a belt or chain, and it read packages, labels, and diverts them in the correct direction, in this case, for storage and handling. Then you have manufacturing technology, automated guided vehicles, driverless trucks that move material along a specific path, direct by wire or tape embedded in the floor of radio frequency, and automated storage and retrieval system, which is automated warehouse where machines are the ones which actually store the parts and retrieve them, using fast-moving stacker cranes, etc. Everything is controlled by computers. Process control, continuous monitoring of automated equipment, in this case, make real-time decisions on ongoing operations. And computer integrated in manufacturing, the entire process, production process is handled by computers. So Lexus in Japan, about 95% of the car is made by computers. So it's one of the epitome of quality, pinnacle of quality in terms of luxury vehicles, but majority of it is produced by machines. So in this case, you're looking at a completely automated environment. Information technology side of the e-manufacturing universe, you have business-to-business transactions between one business and another business, maybe a supplier or outsourcer and the company, whatever it may be. A business to B2C example is Amazon or any others where regular consumers are buying one-off products from online retailers or similar entities. Internet, we all know about what Internet offers in terms of facilitates communication and data transfer throughout the world. But intranet is within the company, communication network internal to an organization, which are protected by a firewall, so only internal employees can have access to that. And then you have extranet, which is internet connected, intranet connected to internet for shared access for select suppliers. So that is, even though this is information, certain information is privy to a company, but you have to share it with some of your suppliers. So you provide some linkages where outside suppliers still can have access, or customers can have access after, or trading partners. That's the extranet. Barcodes, in this case, series of vertical lines printed on a package, and we'll discuss that in bit detail later on. And in this case, radio frequency ID tags, RFID, integrated circuit embedded in a tag, can send and receive information. And in a later chapter, we'll discuss it in more detail. EDI, electronic data interchange, that's used a lot in computer-to-computer exchange of business documents. It's very expensive and inflexible, but it typically, because of the fact it's on a proprietary network. And then you have XML, extensible markup language, which is the language of the internet. Many of the documents now are set up on XML for ease of a common language that is used over the internet. And ERP, enterprise resource planning, again, we'll discuss this in a later chapter in more detail. And in this case, software for managing key functions of enterprise. So for example, Oracle, ERP, or various type of bond, etc., are offering their own ERP systems. Include sales, marketing, finance, accounting, production, etc., all linked together through ERP system. So a university's IT system will also have a similar ERP system. For example, at San Jose State, we have My SJSU, where students can log in and select courses. Faculty can log in, look at their wages, paychecks, and see what courses they are scheduled for, etc., and different type of HR functions. All those are part of the ERP system. Supply chain management, software to manage flow of information and goods in a network supplier, and then customer relationship, which is, again, dealing with the after-sales service as well as product revision focus group side. And finally, we have the decision support system, making computers helping make decisions based on the data that is provided to them. Export systems uses knowledge of exports and diagnosis to problem. And finally, artificial intelligence, where computers are generating their own knowledge based on certain logic that are guidelines that are provided to them through genetic algorithms, neural networks, and fuzzy logic. So that pretty much wraps up our discussion for this area on processes and technology. And we'll see you later for a discussion of another topic on operations management. Thank you.